Continuing with the less than 1 kilogram kind of items we come across every day. Pint of beer. The author is from the UK, so obviously beer is a big thing for them. But so it is for many other cultures and hot tropical countries like India as well. A pint of beer has 300 grams of CO2 equivalent when it's locally brewed cask ale at the pub. So there are ways to save on what kind of container is used as well. 500 grams of CO2 equivalent when it's a local bottled beer from the store, or a pint imported beer in a pub. 900 grams CO2 equivalent bottled beer from the store, extensively transported and kept cold or warm, doesn't matter. So a pint of local ale per day in the pub would be 1% of the 10-ton lifestyle. So for people who do like to imbibe a little alcohol every day, this is something to be considered. And we are talking about beer. Of course, there are other alcohols which could have different types of carbon footprints, but you get the idea. A few bottles of imported larger lager per day, lager per day might be as much as 10% of your 10-ton lifestyle. So as I said, you have to be careful. But the details also include what goes into these things. So footprint of cask of beer from Keswick Brewing Company in the UK. 38% is from ingredients. Electricity is 27%. If you look at the carbon footprint of all the sectors in the world, energy production is almost 75%. In that you get a large chunk going into buildings and transportation, industries, agriculture, and so on. So electricity is always a big thing for industrial activities. So fortunately there are lots of microbrews which only serve local communities and typically serve beer in casks, which all amounts to being environmentally more friendly. And some of the breweries in Mumbai, for example, are also trying to do the right thing by using millets and other kind of grains grown by the local farmers and so on and so forth. Travel and commuting is 10%, freight is 8%, equipment and packaging is 3%. Okay, so just keep in mind, glass versus bottles can make a big difference. This is from this Euronews.com showing glass bottles versus aluminum cans. What is saved when a ton of each is recycled. Bottles are easier to manufacture from silica, so if you recycle 1 ton of bottles, you save 42 kilowatt hours of energy, 19 liters of oil, and 54 feet cube of space in landfill. But in general, the recycling programs for bottles are not as efficient, as good, as extensive as cans. Cans are easier to recycle. So when you recycle a ton of aluminum can, you're going to save 14,000 kilowatt hours of energy. Aluminum mining and production are very heavy in terms of energy use and environmental footprint, so that makes a huge difference. 6,545 liters of oil is saved, and 270 feet cube of space in the landfill is saved when you recycle a ton of aluminum cans. So some people prefer the taste of beer in a bottle or pour it into a mug, but then mug has to be washed as well. And some people don't mind the can. So forgetting about the taste part of it, you can say cans are much better when you want to enjoy a pint of beer. A bowl of porridge, 82 grams of CO2 equivalent when you have a traditional Scottish made with oats and water only. Okay, oats are very healthy, of course, and they are environmentally friendly, and oat milk is also now much better than dairy milk. But if you add dairy milk, so 300 grams of CO2 equivalent results when you make a porridge with about half milk, which is tastier, of course. and it jumps to 550 grams of CO2 equivalent when you have milk and sweet and make it more liquidy. Okay, so a bowl of traditional Scottish porridge is equivalent to a 90-second cell-to-cell phone call. And in terms of consistency, the book says that porridge and cement are similar, and they are almost as bad, equally bad for the environment. Who knew that you have to also worry about carbon so much when you are wanting to just wake up and enjoy a bowl of porridge? Okay, a shower, 900 grams CO2 equivalent if you take a 3-minute efficient gas furnace with aerated shower head. Wasting of water it can be greatly reduced when you use a proper shower head. 550 grams of CO2 equivalent if you take a 6-minute in a typically electrically powered shower, obviously higher. 1.9 kilograms, so 4 pounds CO2 equivalent if you take 15 minutes in an 11 kilowatt high volume electrically powered shower. Other words, taking a cold shower is also found to be very healthy, saves energy. Aerated shower head would reduce the length of the shower and also the amount of water you're going to spend. So if you have a high carbon shower habit, there could be half a ton per year to be saved here, equivalent to a return flight from San Francisco to Vancouver, Chicago to Dallas, or New York to Atlanta. So if we keep in mind that flying around is highly carbon intensive, then comparing to flights gives you a sense of just how intensive other activities are relative to flying around. Ice cream, who doesn't want to get a nice scoop of ice cream or a cone from a van that comes and plays little jingles in the neighborhood? Kids love it. But 50 grams of CO2 equivalent is emitted when a 60-gram popsicle from the supermarket is eaten on the day of purchase, so you don't bring it and store it again and use energy. But this jumps to 500 grams of CO2 equivalent if you are buying from a big dairy ice cream. If you're buying a big dairy ice cream from a van, because the efficiency drops. Supermarkets store in large quantities, more efficient refrigeration systems. These are not as efficient, and these are driving around and wasting a lot of energy as well. This is a diesel van for sale from this website, for example. Okay, so how do you are you going to be the Grinch who tells the kids not to buy ice cream from a van? That you have to worry about in addition to carbon cycle, right? A unit of heat, something like 1 kilowatt hour. You can think of that using solar water heating panel, modern gas furnace, 55% efficient gas furnace which is older, or grid electricity or from the US, or grid electricity from Australia. And you can see that the carbon footprint can vary significantly. Solar water heating panel is efficient, but it's not good enough for heating a room, for example. It's low grade energy you will get. 244 grams CO2 equivalent if you use a modern gas furnace, which would jump to 400 if the gas furnace is old. The footprint is 660 grams CO2 equivalent in the US, whereas it's more than a kilogram if it's in the Australian grid. By a unit, I mean 1 kilowatt hour. That is enough to run a 1 bar electric fire for 1 hour, or enough to boil about 4 gallons of water in an electric kettle, which we talked about before. Additional considerations are involved. So unit of electricity by place would vary like this: 60 grams CO2 equivalent from an Icelandic grid, 220 grams CO2 equivalent from a Canadian grid. UK grid is higher, almost 3 times the Canadian grid. CO2 equivalent in the US grid is higher than the UK. Chinese grid is much more inefficient, and Australian grid is the most inefficient we are looking at here. Okay, so the other additional detail you have to remember is that when you turn on the switch, you are doing what is called additional demand. So there are fixed loads that are already there on the grid. So the carbon impact of using an additional unit of electricity is often higher than we are led to believe. So that's the second point. The first point is, when you think about price, there is a fixed load and there is a controllable price responsive load, and you are often at this end where you can put solar panels, you can reduce electricity use, you can put energy back to the grid, and so on. And there is also demand versus price for controllable load demand curve and controllable load marginal demand curve. So this additional unit is called the marginal demand. So are you going to worry about these sorts of details? Not necessary, but you just need to remember that you are an additional load on the grid that is running constantly. Especially renewables are always running. When you add an additional unit of demand, you are going to change the dynamics of market of energy export can be reduced, let's say from a Scandinavian country to other countries, which means you're supplying less, so the other country may burn more fossil fuel to generate their energy, and so on. So there is these cascading effects which you are affecting just by your own electricity use. So here are the emissions from power generation per unit consumed in kilograms CO2 equivalent per kilowatt hours. The emissions are higher in the US, much higher here. Estimate of total footprint per unit consumed is the other way. So this is direct emissions from the power generation. This is estimate of total footprint per unit consumed. Okay, so you have to understand the difference here, including carbon cost of extracting fuel from the ground, maintaining and building power stations, wind turbines, etc. And the two stars here correspond to the carbon cost or savings of each unit of electricity you choose to use or save. Okay, so this is almost constant for all except for Iceland, which has lots of hydroelectric and geothermal. So right now it's cruising very nicely with no direct emissions and very low footprint, and estimated footprint of marginal demand is also very low. So you can see how the marginal demand concept works. Okay, so it's worth going through these sorts of details basically because energy use is something we do without thinking much. You wake up, you turn on the light, you run the faucet, you take a shower, you get in the car, you go somewhere, or even if you're riding a bicycle, you're having breakfast with porridge, milk, tea, coffee with milk, boiling water in a kettle, etc., etc., etc. I still have trouble saying etc. And there are lots of details of where you come from. In a hot country, you may be able to reduce the temperature of the shower water, or you may be taking a bath with a bucket, which is more efficient often than a shower. You may be forced to take a shorter bath because there is water scarcity, and you may be forced to take public transportation because you can't afford a car, and so on and so forth. So all those details matter, but look at each item in terms of its carbon footprint and how you are doing those things, whether it's having coffee or with milk or ice cream from a dairy or a supermarket or shower, and so on and so forth.